Good morning, and welcome to Achieving Success Through Requirements Analysis. Today, we'll discuss how to reduce risks in highly regulated industries through Innoslate's advanced requirements analysis features. First, let's meet the presenter, Dr. Steve Dam. He's the president and founder of Spec Innovations. Steve participated in the development of C4ISR and the DODAF. He has his ESEP certification from NCOSE, and he's been involved with research, experiments, operations analysis, software development, systems engineering, and training for more than 40 years. Now I'll let you hear from Steve.
So what we're going to talk about today is what's the benefits of requirements analysis, how can I do a better job in performing requirements analysis, and how can Innoslate improve my requirements analysis capabilities. So what's the benefit of requirements analysis? Well, first of all, what do we mean? And most people talk about requirements management, and that's the first thing they talk about. They don't realize that analysis is a critical part of it. If you look at the Wikipedia definition for requirements management, it says requirements management is the process of documenting, analyzing, tracing, prioritizing, and agreeing on requirements, and then controlling change and communicating to relevant stakeholders. This is a continuous process throughout a project. So if you think about that, it's really something you're doing through the whole life cycle of the project. And we highlighted the analyzing portion of this to show you that it is a very, very critical piece of requirements management. Unfortunately, most practitioners spend all their time and energy doing everything but analyzing requirements. What they do is they're spending all their time trying to get the information into a tool and make it work, and then run out of time to do the analysis. So that's most of the problem is that the tools themselves don't have any intrinsic analytic capabilities. You have to do that. You have to come up with a way of doing that, which is basically often ad hoc. So unless you have a structured method for doing requirements analysis, you're not going to be doing it. You're not going to be doing it well or consistently. So one of the benefits of requirements analysis and general systems engineering is basically reduces errors in the design, manufacturing, integration, D&V, and O&M portions of the life cycle. That can lead to reduced costs, fewer scheduled delays, and often even saves lives. Unfortunately, the benefits are not seen until later in the program life cycle, so people often don't spend enough money on it in the front end, and they have the failures in the back end. You can see the graph on the right. This is actually from NASA data, and shows that there's a certain amount you need to spend on systems engineering, which of course includes requirements management and requirements analysis as part of it, throughout that life cycle to be successful and to have a good program. Notice the cost overruns that are in there. It's 50% cost overruns, and that's because people tended to bid low on a lot of projects, and it depends on how these are evaluated. So we've learned a lot from that. Again, the cost overruns, you have schedule slips, you have reduced capabilities, you have program cancellations, and ultimately, if the error propagates into the operations phase, you can have loss of life. So what's a good requirement? Each requirement should be at least clear, complete, consistent, not impose a specific design solution, traceable, verifiable, feasible, and correct. Now, if you look at the definitions for each of these, it's a lot you have to be thinking about as you're reading the requirement and understanding it. If your tool doesn't help you do this, this is a hard job. This is a job that requires a lot of focus and a lot of time. Often, you're just not given it. Nobody's allocated the kind of time and money it takes to do a professional, complete job like this. So how can we do a better job performing requirements analysis? So first, we have to recognize what's the role of the requirements. Okay, so you start with the life cycle. You recognize at the top, I'm starting where trying to understand what the problems are in the current operations and maintenance phase. As I come down, I decide I need to build something, do something to solve a particular problem. I derive the requirements often from architectures, because what we find is that the customers have a vague idea of what they need or what the problem is, but it requires significant analysis, often functional analysis, architectural analysis, to derive what the top-level requirements really are. From that, then you can have a pretty solid basis to start doing your derivation of your system design. And of course, it would be systems designs as you go out, so you start to get more requirements. And then as you go down into actual hardware software acquisition, you're even building more requirements. As you come up the life cycle, V, you see that you're testing against those requirements. You're making sure that they met the specs, all the way up to does it really meet the operational need before it's transitioned into the future state of operations and maintenance. So requirements are developed at the beginning of the life cycle. The resulting components and systems and complete architecture are validated in the later part using those requirements. The number of requirements are increasing as we decompose the architecture. So where do requirements come from? Well, the customer says, I want an iPhone that's bulletproof, literally. So somebody in the field thinking, oh, the communications things I'm working with are so big and bulky, and they're that way because they can withstand the impact in the environments they're in. But the user doesn't see that. They want an iPhone. So how do you meet those needs? Another place is policy documents. You can find in DODI 4540.05, change to enclosure 2, paragraph 2, 1B2. And yes, that's how deep many of these documents and policies are, and how you have to pull things out. The laws aren't any better. They're very confusing and large subchapters and sections and paragraphs as well. But you can derive from those often some very good top-level requirements. So that's often a place I'll start, particularly if I'm working at the architecture level. I need to make sure I'm meeting whatever the current policies and laws are. Another place, as I mentioned just before, was the functional analysis. This is where you take your functional modeling and derive the functional requirements from those models. Architectures, again, that's been a big deal since the 90s at least, and people said, well, I've got all these drawings, particularly if you're Department of Defense, they have OB1s and SB3s and all these other diagrams. So what are you supposed to do with those? Now you got drawings, what does that mean? How do you convert them into diagrams, into requirements? There's a little art form in doing that, or there's some easy ways to do that, and we'll talk about that a little bit later. And of course, finally, models. Here's my requirements diagram. It has everything you need. There's actually a requirements diagram model in SysML that has requirements in it, and maybe that's what you need. Maybe that's good enough. You have to look and see if it is in-depth enough. Did it meet the quality factors you were looking for? So how do I know if any of them are good? It's through analysis. So part of that is having a strong process. So on the right here, you see a process I've used for quite a number of years. It gives you the basic idea of the process. Obviously, there's more to it than just what you see. You're not just looking at, is the statement verifiable? You're actually checking all those quality factors. So that's actually a larger step than what it looks like. But the idea is have a complete process, make sure everyone knows it through training, and make sure you identify the issues and work through them with the customer. That's why that's a critical, important step within my process. Is it a critical issue? Are there options, trade studies, and then resolving the issues with the customer and make sure they're on board and they're in agreement on it so that you can move forward together. Another thing I do is make sure I identify risks. This is an opportunity to determine where are the risks in the system. Remember, a lot of times people think the risk is a management problem. No, risk management is a management problem. It's a technical problem to identify the risks. And of course, ultimately, you want to create a knowledge base so you can query it, you can understand it, you can look at as you go downstream in the life cycle, and you can modify it and trace to it. Of course, that requires, for that ability to create a knowledge base, you need a tool. And you need a tool that supports the requirements analysis, with things like quality attributes and quality checkers. The tool also has to support requirements management. You have to be able to import the data into the tool. You have to configuration manage the information as well. And of course, the tool needs to be collaborative. Nobody works in a vacuum anymore. We have to be able to work together. You also have to have a reviewing capability, so that's where having commenting is very important in it as well. And of course, the tool needs to be scalable. We have thousands and thousands of requirements. Some of the larger systems have tens of thousands, hundreds of thousands of requirements associated with them. Think about a major facility these days. All the requirements that are required in state, local, and federal requirements that they have to meet. It's a phenomenal job. You can imagine if you tried to build a nuclear power plant, how many requirements you have to deal with. So ideally, the tools should be tightly integrated with other systems engineering capabilities such as functional analysis, simulation, and testing. If it isn't, it's quite cumbersome to move the data back and forth or link the data back and forth between tools. It's much easier if it's all together in one place and can easily be integrated and worked with. So, how can Innoslate improve my requirements analysis and capabilities? That's what we're here for. Okay, so some of the features that Innoslate has, we have a requirements view, a baselining capability, branching and forking, so you can actually configuration manage the entire model with that. History, another configuration management feature. That's at the entity level. Quality checker, that actually takes those quality attributes we talked about and walks through them and uses them. And of course, import analyzer to bring the data into the tool. A schema editor, our intelligence section, we have another whole webinar on intelligence you want to hear about, is another checker for requirements as well. And then relationships to other classes so that now I can tie them together. We have everything's connected to everything in the ontology we use, so that's available as well. And auto generation of requirements from the models. As I mentioned, if you have those drawings and diagrams, there's some simple heuristics to go ahead and create the requirements from them, and we take those requirements and put them into your requirements view so you can then analyze it and work with it and improve that document. And of course, supporting the functional analysis and synthesis solution. So the real job isn't just to manage requirements, it's to support the design and acquisition process throughout the life cycle. So I'm going to walk through some of those features I just mentioned. Let's start with importing originating artifacts. We have an import analyzer which directly takes files from like Microsoft Word, Excel through CSV import, doors. You can use plain text, so if you have a PDF file, you can copy the plain text and bring it in. And of course, we bring in our own Innoslate XML file. The Microsoft Word capability is quite amazing. It actually will extract the pictures and put them into the description field. It will also find tables and put them into the description field as well. If you have some trouble with it, there's some difficulty, you may just want to go to the plain text or one of the other options. Of course, it analyzes the numbering scheme to create the parent-child relationships automatically. This is a real time saver. If you use other tools, a lot of them don't do this. They don't take and look at the numbering scheme to understand that they have a hierarchical relationship. So we do that for you automatically. And of course, the nice thing is you have a preview before saving. So if you don't like what's been done, you just go back and fix whatever the problem might be. Another, of course, one of the main features of our requirements capability is our requirements view. This actually gives you the ability to do analysis as well as visualizing the requirement. You can see the view here on the right, the picture. It shows you the requirement, and the description portion of it is shown in smaller text. There are indicators when there's been traceability or verification or satisfied by relationships already provided. That's what the little T and the V are there. Rationale is one of the fields we have available. And of course, our quality score is a function of having looked at the various attributes for quality and shown that they actually meet those requirements. We also have labels, so you can organize the requirements by different types of requirements, so you can separate your functional requirements from your performance requirements and your verification requirements separately as well, interface requirements. Again, a number of those labels are already predefined. If you say, oh, you're missing one, go ahead and add it. It's very easy to do in the entity view as well as the schema extender. So some of the other features I mentioned, the quality checker is just that little button at the top. You hit the quality check button and it will do that automatically for you, give you that quality score. And of course it's configurable. You can adjust the columns, so if you want to work with that. But if you click on any one of these, you have the sidebar will show up the attributes as well. So you have all that available to you. And of course there's a reports button and various stylized reports are available for this, including some of your traceability reports and things like that you're looking for. You also have a baseline button at the top, which lets you configuration manage your document and work with that. And of course, you can have multiple documents as well with this. So it helps you really visualize the information as well. You can open, you can get different diagrams that are available for it, a tree diagram, a system level requirements diagram, things like that are available all within that open button. I mentioned modifying the attributes. There's a number of ways of doing that. Your quality attributes are being shown here on the left. You see that a number of these are auto-generated from the quality checker. I think it's almost all except 2 are done. You could add your own check if you'd like as well. You notice at the bottom we've got a new check button that we added just to say we can add that to the score, and that will adjust against the score as well. The quality checker won't check for it, obviously, because it doesn't have the heuristics built in for that. Again, so you can modify these attributes from this view. You can go into the entity view itself and do it. You can do it from a requirements diagram, a spider diagram. You literally can do it from any diagram that you can see the requirements. You can edit those requirements and edit the attributes with it right then and there. Here's another place where now you can also not only change the attributes, but you can also change relationships. It's our spider diagram. The spider diagram lets you do drag and drop. You can bring in new entities. You can then make those relationships by just dragging between them, the little green circles. And it's very easy to work with and do. And you notice you can edit all that information right there. This is probably one of the most powerful diagrams we have in the tool. Speaking of diagrams, of course, Innoslate is a complete systems engineering environment. So it has all the different types of views and availabilities you're looking for. You're seeing on the right is our diagrams view, just showing you just some of the action diagrams in this particular model. If you notice, there's 72 in all. And as you scroll down, there's more and more available diagrams for you. And of course, real-time collaboration, the ability to collaborate with your team members across multiple views, simultaneously show real-time user status, group chat, and project notifications. You can subscribe, unsubscribe to the project notifications. It'll send you emails. So just all the kinds of things you need for workflow and managing the process are available to you as well. Scale to meet the need. Of course, the scalability we thought was very important. We've tested our enterprise version up to 10 million objects and 1,000 simultaneous users for the entire database, of course. We suggest that you work projects at a smaller level just because it's easier to manipulate and work with the information yourself. Of course, it's responsive even with large databases. Some of the patterns we're showing up here show responsiveness. And of course, you're limited mostly only by the hardware you run it on and the browser you use. And so understand that sometimes you may want to increase the memory on your browser, and that's available as well, and we can help you with that if you have problems. Easy to use. It's got overlays, so you can, when you first come into the tool, it'll show you what different things mean and what they are, and so you can click off that or you can bring those back on through the settings. You have rollover definitions. For example, I don't know about you, but that set of quality parameters is something I never can keep quite straight in my head unless I'm really into it. And so I'll often work in the entity view where I can then put a rollover on complete and it shows up, pops up with the definition of what complete means. And so after doing that for a while, then you're comfortable with it and you work with it. Everything in the tool is drag and drop. It's very easy to work with. Drag connectors between things like that. It's very simple. Sidebar is available for the attributes. That's another ease of use thing. There are no pop-ups and those kinds of things to get in the way. It's all right there. And of course, that also helps with the responsiveness of it as well. It's all been developed to the latest web software tech standards. It was developed from scratch for the cloud, so it's designed for today's modern environments. So in summary, requirements analysis is a critical part of requirements management. To be successful in performing requirements analysis, you need help from your process and your tool. You will know you are successful when the system gets fielded and no one gets hurt. Just go watch Deepwater Horizon if you want to see an example of bad requirements analysis and management. And please request a live demo. Go to our website. It's very easy to do. We're looking forward to talking to you more. Thank you.
Thank you, Steve. That concludes today's presentation. Thank you again for joining us, and be sure to request a live demo.